evening, everyone. In this lecture, we are going to discuss about types of systems. Types of systems. In the last lectures, we discussed about what is meant by types of systems and what are the different signals we are having. Basically, we are having four types of signals. Step signal. Second one is RAM signal. Third one is parabolic, and fourth one we are having impulse signal. These are the four signals we discussed in the last lecture. In this case, type of the system. There are different types of the system. We can say that type 0 system, type 1 system, type 2 system. What is meant by type 0, type 1, and type 2? Similarly, we are having an order 1 system, first order system, second order system, and third order system. What we are going to do in this lecture is, I am having different types of the system as well as different order of the system and different test signals, that is a step signal, ramp, parabolic, and impulse, like that we are having different types of signals. Now, whenever we are having a control system, whenever we are going to find the stability of the system, first we need to know that which type of signal is it. Whether it may be a step signal. Step signal, already we know that what is the input of the step signal? 1 by s. What is the input of the ramp signal? 1 by s square. What is the input of the parabolic signal? 1 by s cube. Impulse signal 1. Like that we are going to consider in the last classes. Now, how we are going to find out the how many first type of the system. Type of the system, how we know that which type of the system is it? Type 1 or type 2 or type 0 system, how we are going to know. You consider any transfer function. Any transfer function is, I am considering s divided by s into s plus 1. I am considering s divided by s into s plus 1. What is that? At s is equal to that means what is the poles and zeros? Poles and zeros is nothing but from the numerator we are going to get zeros. From the numerator we are going to get zeros. From the denominator we are going to get poles. Now how many poles and zeros are there? 1 0 and 2 poles. 2 poles is s is equal to 0, s plus 1 is equal to 0. That is s is equal to minus 1. S is equal to minus 1. These are the 2 poles we are having. At these 2 poles, how many poles are at the origin? In this case, only 1 pole at the origin. Only 1 pole at the origin, so that we call it as a type 1 system. Type 1 system. That means that how we are going to find the type 1 system or type 0 system is nothing but if the number of poles present at the origin, if there is no poles at the origin, that we call it as that is a type 0 system. If the number of poles present at the origin is 1 pole, that we call it as a type 1 system. If the number of poles present at the origin is 2 poles are there, so that we call it as a type 2 system. That means, for example, what is the example for type 1, type 2 system? That is an s divided by s square into s plus 1. S divided by s square plus 1. So in this case, how many poles are at the origin? 2 poles at the origin. So that this is a type 2 system. Similarly, what is the order in the denominator? What is the order? S square into s, that is a third order system. Third order system. Right? That means a type of the system. How we are going to define a type of the system is nothing but definition of type of the system. Type is defined as it is defined as the number of poles. It is defined as the number of poles at origin. At origin is called type of the system. Type of the system. It's called type of the system. Example. Example is that s divided by s into s plus a. S divided by s into s plus a. Which type of the system is it? That means how many poles are at the origin? S is equal to 0, s is equal to minus a. So that this is a type 1 system. Type 1. Similarly, what is the next example? S into s square into s plus a. That means an s is equal to 2 zeros and s is equal to minus a. This is we call it as a type 2 system. Type 2 system. Why? Because there are two poles at the origin. Next one, s divided by s plus 1. Which type of system? What are the poles? S is equal to minus 1. So that there is no pole at the origin. So that this is a type 0 system. Type 0 system. This is a type about the type of the system. Type of the system, it is defined as the number of poles present at the origin. We call it that is a type of the system. Now, how we are going to do the analysis of type 0, type 1 and type 2. Analysis of type 0, analysis of type 0, type 1 and type 2 systems. Analysis of type 0, type 1 and type 2 systems. How we are going to find out? For type 0 system, first we need to consider for type 0 system. For type 0 system, for type 0 system. Type 0 is nothing but, what is that means? Type 0 is the number of poles at the origin is 0. It means to find that the first step input, first we need to consider first step input for type 0 system. First step input for type 0 system. First step input for type 0 system. The first one is consider open loop transfer function. Let us consider open loop transfer function. That is g of s into h of s. That is g of s into h of s is equal to k into 1 plus t1s, k into 1 plus t1s whole divided by 1 plus t2s. We are considering type 0 system. So that 1 plus TAS into 1 plus TBS. 1 plus TAS into 1 plus TBS. For step input, now we know that already in the last lectures we explained. For step input, what is an KP? Position error constant. KP is equal to S into limit s tends to 0. Limit s tends to 0. G of s into h of s. G of s into h of s. For example, that is the KP for ramp input, it will be going to an change, right? That means now what is the KP value? Limit s tends to 0. G of s into h of s. Now what is the KP value? Now take this. KP is equal to limit s tends to 0. G of s into h of s value how much? K into 1 plus t1 s into 1 plus t2 s whole divided by 1 plus TAS. 1 plus TAS into 1 plus TBS. If you substitute s is equal to 0, then what you are going to get? KP is equal to some constant K we are going to get. KP equal to we are going to get some constant K. Similarly, what is the steady state error? Error that ESS is equal to 1 divided by 1 plus KP. That means ESS is equal to how much we are going to get? KP value how much? 1 divided by 1 plus K. This we call it as a steady state error. Steady state error. Just very simple. For type 0 system, what we are going to take? G of s. Let us consider any transfer function like the that must be a type 0 system. Type 0 system is nothing but there are no poles at the origin. If there is a no poles at the origin, that we call it as that is a type 0 system. For step input, what is that formula we are having? A position error constant. Kp, Kv, Ka already we derived. Kp is equal to limit s tends to 0, g of s into h of s. So we are going to get Kp is equal to limit s tends to 0, k into 1 plus t1s. Just I am substituting g of s into h of s. If I am substituting the limitations, then we are going to get Kp equal to k. And similarly, what is the steady state error constant? ESS is equal to 1 divided by 1 plus Kp. That means ESS is equal to 1 divided by 1 plus k we are going to get 1 plus k. And similarly, for type 1 system, what will be happen? For type 1 system, what we need to do here, see the same thing we are going to get. How we are going to change. For type 1 system, this is a type 0 system, step input you apply. Now for type 1 system, what will be happen? What is your g of s? G of s into h of s is equal to how much? G of s into h of s is equal to how much? K into 1 plus t1s into 1 plus t2s whole divided by here only we are getting an s plus 1 by tas into 1 plus tb. See here, what is the difference? In the last thing we are not having an s here. Why? Because that is a type 0 system. Now this is a type 1 system. Now apply the same thing, Kp, position error constant, which is equal to limit s tends to 0, limit s tends to 0, g of s into h of s. Now what will happen? This one, limit s tends to 0, k into 1 plus t1s into 1 plus t2s whole divided by s into 1 plus tas into 1 plus tds. Now if I am substituting s is equal to 0, this complete value will become how much? K divided by 0, that will become infinity. Now what is the value of Kp for type 1 system? Kp equal to infinity. Then what about the ESS? ESS is equal to how much? 1 divided by 1 plus Kp. What is the Kp value? ESS is equal to 1 divided by 1 plus infinity. That means ESS we are going to get 0. ESS we are going to get 0. This is for type 1 system. Similarly, we can do for type 2 system. Similarly, we can do for type 2 system. This how we are going to do for type 2. For type 2 system, what will be happening for type 2 system? That means g of s into h of s is equal to, we need to take k into 1 plus k1s 1 plus k2s whole divided by how much? S square we are going to get. That is 1 plus ta of s into 1 plus tbs. Small change. Again, what is the Kp? Kp is equal to limit s tends to same procedure. There is no change. The same procedure we are going to do. Limit g s tends to 0, g of s into h of s. Now what will happen? Again we need to substitute. Now what you are going to get? Kp is equal to k. That means if I am substituting again k divided by 0 we are going to get. K divided by 0 is infinity. Kp is equal to infinity. Then what about that ESS? ESS is equal to 1 divided by 1 plus Kp. Again you are going to get 1 by 1 plus infinity, which is equal to 0. Now we are getting in 3 cases. What is that? For step input, type 0 we derive, type 1 we derive, type 2 we derive. In the case of type 1 and type 2, what is the Kp and ESS value? Infinity and 0. Only in the case of type 0 system, what is the Kp value? Constant. Kp is equal to K. And what is the ESS? ESS is 1 divided by 1 plus K. That is for step input. What we derived till now is for step input, here I am writing. For step input, this is a type 0, type 1, type 2. what you are going to get step in code. This is a steady state error. Sorry, first we need to write down Kp value. What is the Kp value here? K infinity, infinity. Right? Here what is the steady state? ESS. We are going to get ESS is 1 divided by 1 plus K. Here 0. Like this we are getting. This table, anyhow, I am going to explain last. That is a very, very important table which we are going to use in our GATE examination format. Now, similarly, first step input is completed for type 0 completed, type 1 completed, type 2 completed. Next, what is the input we are having? For parabolic or for ramp input. For ramp input. For ramp input. Now, for again, first you need to consider type 0 system. For type 0 system, what will be happen? Type 0 system, what will be happen for type 0? You need to consider g of s into h of s is equal to limit s tends to 0. Sorry, g of s into h of s is equal to how much? G of s into h of s is equal to, we know that that is your name. G of s into h of s is equal to what is the value? K into 1 plus T1s into 1 plus T2s whole divided by type 0 system. So we can write 1 plus TAS into 1 plus TBS. 1 plus TIS into 1 plus TBS. Now, what is our Kp value? Kp is equal to limit s tends to 0. We are going for a ramp. That means a ramp Kb is equal to limit s tends to 0. S into G of s into h of s. S into G of s into h of s. Right. Now you substitute. Then what we are going to get? Kb is equal to limit s tends to 0. If you are substituting s value 0, then complete Kb value will become 0 only. Now what is a steady state error? We know that steady state error ESS is equal to 1 by Kv. 1 divided by 0, how much you are going to get? Infinity. Infinity. We are going to get infinity. This is the type 0 system. Similarly, for type 1 system. Type 1 means, again we need to take, this is the same thing, type 1 system. Type 1 system is what is the change? We are going to get S into 1 plus TAS into 1 plus TBS. Now similarly, what is the Kv value? Kv is limit s tends to 0. S into G of s into h of s. S into G of s into h of s. In this case, what will be happen? Numerator in the denominator, the s value will be going to be cancel. Then what we are going to get? Kv is equal to K we are going to get. Then ESS is equal to, we are going to get 1 by Kv, which is equal to 1 by K. 1 by Kv, which is equal to 1 by K. That is for type 1 system. Next, which type we need to go? Is type 2 system. Again, for type 2 system. Type 2 system means, again the transfer function will be going to gonna change. G of s into h of s is equal to what we are going to get? K into 1 plus T1s into 1 plus T2s whole divided by s square into 1 plus TAS into 1 plus TBS we are going to get. Now limit, what is our what is your Kv value? Kv is equal to limit s tends to 0 s into G of s into h of s. S into G of s into h of s. Now what is the value of this thing? SS 1 by s we are going to get in the denominator. If I are substituting that value, the Kv value, how much it will becomes an Kv value, it will becomes 0. Sorry, 1 divided by 0 you are going to get. That means 1 divided by s. S means 0. That means infinity we are going to get. ESS is equal to again 1 by infinity, which is called it will be equal to 0. This is for type 2 system. For type 2 system, we are going to get infinity and 0. And third case, what is the third case for which input we need to consider? For parabolic input. See, for parabolic input, the third case is for parabolic input. What is the parabolic input we are having here? For parabolic input, again we need to take type 0, type 1 and type 2. Again we need to take type 0, type 0. For parabolic input type 0. Type 0 is nothing but what we are having. That is g of s into h of s is equal to k into 1 plus p1s into 1 plus p2s whole divided by 1. For type 0 means only there is no poles at the origin. 1 plus TAS into 1 plus TDS. Now what is your Ka acceleration constant? Limit s tends to 0. Limit s tends to 0. S square into g of s into h of s. Now what will be happen if you are substituting the same value? In the denominator we are going to get in the numerator we are going to get s square. That means it will become k equal to 0. Then ess is equal to 1 by 0. That means it will become an infinity. It will become an infinity for types 0 system. And next for type 1 system. Again here we can write. I am not going to write. I am explaining. Type 1, for type 1 what will happen? You are getting a s in the denominator, that is g of s into h of s is equal to k into 1 plus t1s 1 into 1 plus t2s whole divided by s into 1 plus t1s. Now what is your kv value? Sorry, ka equal to limit s tends to 0. Limit s tends to 0, s square into g of s into h of s. S square into g of s into h of s. Right. Now what will happen again? S square is nothing but and the denominator you are having as 1 by s. So again it will becomes 1 by 0 you are going to get, that is an infinity, and ess will becomes an 1 by infinity which is equal to 0. This is our type 1 system. Similarly you can take type 2. Type 2 means what you are going to get? This is type 2, this is s square. S square will be going to be cancel, and Ka value will becomes K you are going to get, and ESS value will be get 1 by Ka, which is equal to you are going to get 1 by K. This is an analysis for a different, totally 9 cases we analyzed for type 0 system, type 1 system, type 2 system for different inputs. First we consider step input, second we consider ramp input, and then parabolic input. Now finally I am going to conclude these things with a simple table how we are going to remember all these things. The thing is we can take here type of the system, type of the system here, type of the system, and next we are having an error coefficients, error coefficients, error coefficients. That means what is the type here? We can take 0, 1, 2 type of the system. Error coefficient we are having Kp, next one Kv, and next one Kl. Next we are having a steady state error, error coefficients, and then steady state error. Steady state error, steady state error, steady state error. That means an ESS. Steady state error. For step ramp parabolic, for step signal, what is this? Ramp. Already what we taught till now, that is that we are formulating in step ramp and parabolic. Now for type 0 system, what is the value? First type Kp value 1 by 1 plus K. Kp value in this case is 0. Similarly here 0. Here you are getting 1 by K, here you are getting 0. 0, 0, 1 by K. Yes. sorry, 0, 0, here we are getting infinity. Kp value to infinity. Infinity, infinity, 0, k infinity. 0, k. 1 minute, kp is 1 divided by 1 plus k of, oh, we are writing in the second manner. Okay, these are the positional error constant, right? Kp equal how much we are going to get k. First case kp equal to k, and for these two things we are going to get infinity. And second case is this is a 0, k and infinity we are going to get. Here we are getting 0, 0 and k. Okay. That means the diagonal elements are at a constant. The upper triangle is at a zeros and the lower triangle is at a infinity. Infinity. Here also we are going to get 1 by 1 plus k. 1 by 1 plus k. After that what will be happen? 0, 0. We are going to get 0, 0. Ramp signal what we are going to get? Infinity. Infinity 1 by k. 0. Again after the parabolic we are going to get infinity, infinity. Infinity, infinity. These are very simple. You can note these things. Again, here the upper triangle is an infinity, and the lower triangle is an zeros. Say for steady state and that ramp signal. This is the table is very important. For type 0 system, Kp is k. Remaining all are zeros. Kp value 0 and k value 0. Okay. We are having we can conclude by if we know this table we can find that any type system, whether it is a type 0 system or type 1 system, or whether it is a step signal or ramp signal or parabolic signal, anything we can find very easily if you know this table. Whatever till now we did, this is the table.